everybody.
Hello, hello.
Hey.
Well, thanks for joining us. So, giving people a couple seconds to tune in. So, we're gonna do another cool edition here at Threat Thursday Live. This is probably what, like our fifth or sixth one now, I think, Tyler.
We've done quite a few of them. I think this is the second time that Jake's been on.
Yep. So, yeah, and if you guys haven't noticed yet, we do yet again have another awesome returning guest, Jake, the man, the myth, the legend himself. So, we're going to talk through something pretty cool with everybody today, and that's JakeRAT. Obviously, it's something very cool that's been put in place for our Linux threats, some of the container fund stuff we've been doing. And all in all, it's a really interesting concept and tool, and we definitely wanted to have you on to talk about it with us today as we showed it off, Jake. So is there, I guess before we dive in and kind of show off the screen, show what you can do a little bit, is there anything you want to tell the people about this cool little capability?
Yeah, so look, as the name implies, it's a rat, right? So basically a remote administration tool or remote access Trojan, however you want to look at it. One of the things that I think we were chatting, I think the onus or the impetus for this really came from, if I recall correctly, I think it was when we did the systemd persistence. So we were talking about, hey, we're going to go and show systemd persistence, right? But then the question became, persist what? Right, and of course we could have persisted the Scythe agent, right, or the basically the Scythe agent to call back or something. We chatted a little bit about it. And it'd be really cool would be to stand up just a small external rat that literally and please don't get your hopes up here around around like does all kinds of craziness, but basically a small C2 server. It's written in Flask. That basically has functionality to go and issue commands and receive responses from different different endpoints and ID, grabs the host ID for that endpoint and sorts it by, sorts out all the commands and responses there. And so no frills, right? This is not, doesn't do its own persistence, does none of its own stunts, but of course, once you have the ability to execute arbitrary code on arbitrary commands on a system, that opens the key to everything else, right? You can run curl or wget to download other binaries, right? And so, again, it was fairly interesting to put together. I say fairly interesting. It wasn't like this. Shouldn't imply like this ginormous amount of work, but to test back through it and get list the commands, delete commands, what have you. Pretty slick. And then it also has the convenience of not requiring you to call out to any specific infrastructure. You can host the C2 server anywhere you want, right? So we set that up through environment variables, that basically that populate up to the rat. And now we've used it a couple of other times. So I think the first time we used it with systemd persistence, and again, my memory might be fuzzy on this. That was the first time, but we issued it as a Python rat. And the following month, I know we were doing some other, and I don't know why my brain is not working on which persistence it was, but doing some other persistence. And do you remember?
I want to say it was
the Docker one was the most recent one, and then I believe the .bash rc is another another one. Which that one, I'll tell you, from a detection standpoint, that is a tough nut to crack, because it's like how are you going to monitor just that file? Like you're not gonna have that anywhere, that you have to go onto the machine and see if anything was changed. That's a good persistent spot where it is very hard to even notice that anything is different.
Yeah, definitely. I couldn't remember that second one. I knew there was one between that and the container, right? Because I ported the code to C for, if I recall correctly, for the bash RC one. I know we ported it to C and then used that in one of the two threats, and then again used it in the Docker threat as well. And so, yeah, the bash RC one is really difficult, right? Because bash RCs, it's individual to the user. Every user gets to update their own bash RC. I update mine pretty regularly, in particular aliases, right? Because I'm one of those bad typers, right? So, I have some standard aliases like GURP, right? Because I mistype grep all the time. And so, but oftentimes when I'm working on a project and I've created like these stupid directory structures, right? I have these little shortcuts, right? Where I can type, like CD AI, and that'll take me into my AI project working folder, right? Instead of having to type all that out and remember it. And so obviously, like these bash RCs, because they're editable by the users, yeah, it's super tough to go pull something out of there and say, oh, this thing shouldn't be there, right?
We had an issue with that because in almost all of our threats, like we've shown, we provide some kind of Sigma rules or detections or a screenshot of what it looks like in Splunk. For this one, we just listed detection opportunities and had it in there for kind of the the local defenders to kind of suss it out on their own with their own tools. Yeah, that was a good one.
Yeah, and I think really there, but I think it highlights, a really critical point, right? Because any threat actor that manages to gain shell access, right, however that is, they can modify files in a user account, now can persist in that user account every time they log in. And so the only thing that I can think from a detection engineering standpoint would be to identify unknown processes or unexpected processes running from the running every time the user logs in. But I mean, the complexity there is huge because what does unexpected mean, right?
Yeah.
In that context, again, I have stuff that frequently, right, runs every time I kick off a bash session, and so which is when bash RC gets processed, and so yeah, that one's tough, man. But yeah, then we rolled in with a C build of it, right? So the fully compiled build, and again, the first one I said we wrote it in Python, and then we used uh, PyInstaller, right, to create an executable. And if I recall correctly, it was huge. It was like 8 megs or something, right?
It was very
Which
chunky.
itself is well, look, all PyInstaller stuff's pretty beefy, right? Because it's bringing the Python interpreter with it, and all the Python libraries that are necessary with it. But then as we moved up to the C build, it came down into a few, 100K, something like that. And so, that, by the way, using the different languages is very intentional, right? Because, even though the RAT functions identically, the RAT functions identically between the two, the two versions, there are unique detection engineering opportunities for PyInstaller, right? Or potential detection engineering. I mean, you can't say PyInstaller, therefore bad, right?
Yeah.
Because lots of stuff uses it non-maliciously. Then as we moved into the Docker one, I actually I don't know if we even discussed this, but I came across this month's threat with Docker. I came across a small problem with JakeRAT, in that I had assumed, I don't know why, but I thought, well, I guess because all my test systems had it, that there would always be a host ID, right? And containers don't have a host ID. And so all of a sudden now I'm in this problem where, and I've written JakeRAT, to say, well, since the host ID is how we determine, this command is meant for me, what am I going to do now, right? And so I basically would bail out, right? So JakeRAT's failing in the Docker container, and I'm like, man, what the heck, right? Having to go in and troubleshoot a little bit. There's a JakeRAT debug flag, by the way, that prints verbose output for you. And I saw the verbose output. It's like, no host ID. I'm like, yes, there is. And go over and check. It's like, no, there's not already. Okay, well, let's solve that problem, right? And so that binary version is just a little bit different than the one we use in the bash RC, and that it accounts for that issue, right? In containerization. But this month's thread I thought was really interesting because we actually use JakeRAT there, but are running it inside a container, and basically we're tying it to Polkit, if you're familiar with that, at least for the process camouflaging piece. And I think we call both the binary and the container Polkit helper. And you're not actually downloading them from a container registry. And I've seen some folks that have kind of bet the farm on that, where they're like, no, we only allow connections to legitimate container registries. And okay, but you can still use the Docker save and Docker load commands, right? I can install something from any registry and build this malicious container as I did, and then save it out as a tarball, and then download that to the machine and do a Docker load, and it'll load right up, right? And then we run that as a privileged container, right? So we load it into our local repository on the machine, and then run that as a privileged container. So now JakeRAT, even running inside the container, has access to all the basically the entirety of the file system for the container. So
yeah,
interesting. Go ahead.
That was a very, very sneaky way that you had done that. So when we were going through and deploying the threat, to do the write-ups and whatnot and check it out, I was like, why does he have 20 some odd files in here that we have to download? And then as I had read through it, and it was like, oh, you broke it all down into chunks, into pieces, and you essentially just concatenate it after you download it and then load it that way. And I was really like, this is really something super neat. I was like, what a an interesting way to kind of get around, like you said, if you can only pull from certain repositories or something like that. What a great way to kind of get around that. And again, difficult to detect, right? Because if you're monitoring for maybe like network connections out to certain repositories or things like that, it's like to catch a locally loaded Docker container. Yeah, that was neat. That was another really interesting way to kind of get around a lot of stuff.
Yeah.
When you think about this too, it's really cool to see it from a threat perspective, because we're taking something like, granted, it is not anything super high speed. It's not like a full-fledged Nighthawk C2 or whatever,
Right.
but it's still capable. It still does what you need it to do and provides you extra capability.
Yep.
On top of that, we're seeing multiple different uses and different ways of implementing this. So you're almost getting to see how you would expect from a threat actor, the traditional evolution of TTPs and tooling and the way they do stuff over time. We're just seeing it in a much more condensed timeline of month to month.
Yeah, and so a couple of notes there, right? One, from the download perspective, yeah, fantastic. And I actually am dealing, like, the reason I'm downloading, I want to say it's 15 or 16 files, whatever it is, really comes down to a limitation with VFS, right? I say a limitation, but I think we have, for lots of operational reasons, our default deployment with VFS creates maximum file sizes of 10 megs. And so I broke it into 9 meg chunks. The actual Docker save file, break it into 9 meg chunks and download those. And then to your point, concatenate them back together. But I'm actually kind of happy that we had that, as our default size there, because I know a lot of folks look for large file downloads, and
Sure.
large, of course, every year the size of large goes up. And then separately to, what does large even mean? That's very abstract, but okay, large file downloads. And so we are doing lots of small file downloads, not a large file download, right? So
falling under
absent
thresholds.
yeah, exactly that. You're beating, and again, I see this in intrusions, right? Again, I'm not sure I would have done it, with the threat, absent that kind of built-in, setup there with the 10 megs, but it actually was a hugely beneficial thing. Then the second thing, Trey, that you were kind of, I think, alluding to, is that this does give us a chance to go look at additional threat actor TTPs, because the rat is just like, the deployment of the rat is just the first piece, right? Get it into bash RC so we persist. Get it into a system D service so we persist. Deploy it as a Docker container so that we're running, we have execution. But what happens next, right, is the actions on objectives. If we think about that cyber kill chain, actions on objectives, and when this rat first calls back, there's a standard list of commands like ID and ls-l temp and etc.
Yeah, basic discovery and situational awareness.
Exactly that, right? But then you have the option, right, to even pre-deployment for the rat, or as it calls back every JakeRAT interval seconds, basically to issue brand new commands to it, so that you can change up your actions on objectives independent of the Scythe implant. Because when the Scythe implant deploys this, it's just off to the races until it cleans it up, right? So you can then go and deploy your own commands and run those. And so I like the way that gives additional flexibility for, really additional flexibility. And if you look process hierarchy, nothing's coming from the Scythe implant except the deployment of JakeRAT. After that, it's everything's coming out of whatever we camouflage JakeRAT as.
Mm-hmm.
Yeah, sure.
Yeah, it's a really interesting and cool setup. We've been talking about it here for about 14 minutes or so. Tyler, you want to share some screen to show it off real quick?
Just having the same thought. I was like, what a great segue into actually showing what this can do. So up here on the right, I have our Ubuntu server that is that we're going to deploy JakeRAT from. So I'm sharing my whole screen, so hopefully no one sends me a message with anything bad in it. But so simple enough. You just download from I say the only one who sent it to me would be Trey. So so you download the c2 server.zip, which is in our VFS, unzip it, and then Jake was kind enough to actually have our keys in here, our .pem files. So that was great to be able to already just have those in there. And then to run it is just as simple as these two commands. So we're going to export our Flask app as the ratserver.py, which you can see here on the right. And then we're just going to run, I'm going to do a recursive search. Flask run, you give it the cert and the key and the host to just anything, and then run it. And I'm pretty sure I turned on the debug in my in my standing up of it. So once I go to it, you should see, see over here on the right that I am accessing it. It has it open. We have the, this is how you add commands in there. You can see that you can delete commands if they're not issued yet in there. And then you can view the output of the commands over here. So Jake, if I understood it correctly, you can go into add new command. You can type whatever you want. You do ls lha. You add it. You can see over here that it was added to the rat, and then it essentially is like queued up, right? So if the check-in is what, every 5 seconds by default or something like that, right?
I think I have it set to 30 seconds if I recall correctly in the default build, but you have the ability to change that via environment variables, right? As you deploy.
Yep.
So yeah.
So give it a little bit to check in. If you change your mind maybe and you want to delete it before it's issued, you can hop in there. This one must already be issued, so that isn't an option. And then over in the view commands, you can see the select client, which is our client ID that we have. I've only ran it on this Ubuntu machine on the right here. And then down, you can see all of the different commands that we ran. I think from cat etc password to ls, I believe those are all the initial survey commands that it runs as soon as it loads up. And then Trey and I ran who am I at the same time earlier. But you can go in, you choose which command you want to see in the output that you want to see. You see on the right here that it queries it. And then the output is for this one is just as simple as Ubuntu because it's just doing a who am I. I was also how you were saying before how you could have it, do wgets or interact with files or things like that. So I had to go in and just echo a file over to temp just to see it interacting with the system a little more. Do a ls home and see. So yeah, like you said, not super complicated, not super crazy, but very functionable. It's great to be able to like deploying this with Scythe is kind of like a stage 1 almost. You can go in, have Scythe do the persistence or the Docker mechanisms we were talking about, bash RC that we were talking about, and then it stands up this additional C2, this additional rat that'll give you basically 2 comms, 2 different ways out, almost like a stage 1, stage 2 campaign to again provide you with how threat actors are really doing it, right? Once you have an initial access, you're going to probably you're going to install something, you're going to do an ingress full transfer, something like that. But then you're going to move on to your secondary channels, right? And this is exactly what this is emulating.
Yeah, it's exactly
I want to stress that here too. Jake hit on it a little earlier that it's very much an alternate means. And what's cool about this is once it kicks off, it's completely separate from the Scythe implant and what you have going on. So everything you have in your preset campaign is still going and actively doing its thing, while JakeRAT's over here on the side doing something else. Mm-hmm. So it's a really cool concept and really interesting way to improve the way people are doing their threats now with the platform.
That's it. And I was going to mention here, it's exactly that. This is the kind of thing that as a threat actor, right? I would absolutely, mass deploy, right, without thinking about it, because it's the kind of thing that can be, at least from the on-target presence, right, rewritten like that, right, and changed up immediately, right. And so I look at Scythe, right, where Scythe kind of fits into this, right. Scythe is emulating the actions that a threat actor took to get that stage 0 down, right. And I look at this, as just the burnable implant you can go deploy everywhere. It runs those initial survey commands, sends back up to, like the ID, what groups am I in? Is there anything interesting in Etsy? Just the basic survey and situational awareness commands to quickly identify, is there something I want to deploy a stage 1 to, right? Or basically a more fully fledged stuff I'm not going to deploy everywhere, right? And so, then yeah, I can quickly filter that. And by the way, then use the C2, right, to send a curl command or a wget or whatever, right, to go deploy that stage 1 and get rid of my stage 0, right? And so, and that's really what we're looking at here. It's Scythe deploying JakeRAT as this, again, whether you prefer stage 1, stage 0, or whatever. I'm a comp sci guy, so I'm going to count from 0.
It all starts at 0.
All starts at 0, right? But Scythe's, emulating whatever that exploit presence is that gets the threat actor on target to go deploy the first thing, right? And so, yeah, I'm pretty happy with it. It works pretty well. I don't think you had the actual binary run, like the C2 server is up, but I didn't see the binary calling back. You'll see that in the logs as well. as it starts to call back. And I think you were getting to that at the end there when you CD'd in for the
Yeah. I was about to run the thread, and I was like, yeah, we're almost out of time anyway, and I don't.
Yeah, it's
all
good.
I'll break it down, but yeah, like that is exactly how we ran it. We would stand up the server and then deploy the thread itself, and the thread goes in. It creates persistence. It runs those survey commands, executes it. It's it's very well packaged. We like it a lot, and all of the different iterations of it that we've shown to really kind of show again just a lot of different ways of how to kind of achieve the same thing, which is something that we talk about almost every one of these. You know, there's a 100 different ways to skin a cat, and we're just showing some different ways that you're able to utilize this.
Yeah, and I think too, just kind of to that point, right? JakeRAT's not the interesting part, right? As far as I'm concerned, right? It's to your point, the bash RC persistence, it's the system D persistence, right? And you know, but like I said, the whole onus of this came from me and Trey chatting about, well, okay, we're doing persistence, but what are we persisting, right? And then wanting to show something that not only, you know, from a persistent standpoint, not only is you know, obviously creating or showing that TTP, but then, you know, anything that we would persist would necessarily make callouts, right? And so would necessarily, you know, have to have some way to get further commands and downloads and whatever. And so this kind of became that placeholder, I guess, for like what we're going to put in here. So I no doubt we'll do more Linux persistence stuff in the future because, man, Linux is a hard thing to check persistence around. And you got to get good with the detection engineering. There's tons more of those little bash RC style hide it kind of things. And yeah, anyway, I'm excited about some of the stuff we've got coming up too. And
I'm excited. We're pretty much at time there before we cut it out. Do we want to give them a little hint on one of the next ones that's coming up, Jake?
Yeah, if you're good with it, I'm good with it, right?
Yeah, I think it'll be really cool.
Yeah, so we're doing 2 Windows threats this month. One of them is looking at EDR killer style malware that ultimately is using bring your own vulnerable drivers. So legitimate drivers that we're not doing any binary exploits. It should be really clear, right? We're using stuff that doesn't do appropriate checks, but allows us to go kill, processes, right, of any variety. And so we're going to, do some basic create a threat around that. And then the other one we're looking at is a Windows RAT, kind of similar to this. But we're going to, do some additional functionality checks and stuff that we would do on Windows as opposed to a Linux system, like screenshotting and whatever. So a little bit, some fun stuff coming up. I'm excited, and yeah, it'll be a good month.
So. Definitely, I think it'll be fun. Well, with that, guys, you guys got any parting words for them before we cut it?
Keep on doing detection engineering, man. I mean, that's that's what this is all about.
Yeah, I say I've really learned a lot about because I have not really had a ton of experience in doing detection engineering on Linux systems just because it's not really something that I've ever really had to before. So from installing, we have the Sysmon for Linux installed on there now. And so trying to learn some more of the detections for Linux has been a lot of fun. And like you said, it is difficult. It is a lot more difficult than doing it on a Windows machine. So yeah, looking forward to some more detection opportunities and hope everybody checks out our detection opportunities that we have and has a lot of fun with deploying JakeRAT.
Awesome.
Yep. Well, that wraps us up. Thanks for coming out and hanging out with us for a bit, Jake. As always, Tyler, let's get back to work.
Awesome.
Keep on learning. Stay frosty, cyber nerds.
See you guys.